Hello, welcome again to Gearjunkies TV and a new video. Today we're doing a percussion patch with the Behringer 2600. The Behringer 2600 is, as we know, an ideal synthesizer to experiment with sounds. In this second patching video I will create a percussion sound that can be tuned and tweaked to taste. I started with the idea of a bongo sound in mind, but as I progressed it became more of a metallic steel drum sound. Well, no problem. This way we can use it in even more sunny music productions, I guess. But first, if you want to see more, you can stay informed about all our videos. Subscribe to our channel by clicking the subscribe button below the video, and you can hit the bell button to get notifications when there is something new on our channel. Before we start, you can find the finished patch sheet available for download. There's a link below the video. And please let us know if you have any questions or suggestions in the comments. We will be happy to try them out and assemble ideas for future sounds. Okay, let's go to the patch. First, the inspiration for this percussion sound came from a video I watched about the famous Buchla bongos. You can look for them on YouTube and you will find many examples. They sound very musical and natural, but of course there are multiple challenges in creating something similar on the 2600. First, the Buchla works with low-pass gates with vectorals, and these cause a delay or decay that is often described as a ringing sound, which makes the sound fade in a way that sounds very natural. The 2600 has none of these, so I had to improvise. Second, the 2600 has multiple oscillators, so we wanted to use them to make the sound a bit thicker and complex, evolving, so to speak. Like a player hits the surface of a drum slightly different each time. Let's take a look at the patch. From left to right, I used two oscillators to produce the sound, oscillator 1 and 3. I've set them to a range of about 3 kHz on both oscillators to create some kind of a high, mid-high range of sequences to play, because we can play this percussion sound by changing pitch on a keyboard, which I will show you in a minute. The second oscillator, I've used the sine wave output to use as an LFO for the first oscillator. This creates more higher harmonics in the oscillator, and therefore the sound will become more alive, so to speak. Looking at the filter, I've just set it slightly above completely closed, and we control it with the ADSR, which I've set to 3/4. Then the oscillator 1 is fully open, so we will hear this one playing in a minute. And we will also hear oscillator 3, and the 2600 has a direct input for the pulse modulated waveform of oscillator 1, but I wanted to use the pulse on both oscillators, so I patched this one into VCO3 input and set that to about 1/2. I'll turn it down for now, so when we listen to the sound we can hear how it builds up in a minute. Then the output of the filter I've also routed to the ring modulator, which I set to DC, and the VCO2 input is then patched into the AR envelope generator. Now, why did I do this? I wanted to have a more thicker sound, so this way I create, from the same sound coming from the filter, I create a second sound that goes through the ring modulator, which is used as a VCA, and then they both go to the VCA input here. So we'll have the ring modulator as audio signal as well as the output from the VCF directly. Now the VCA is controlled by the AR and the ADSR. I did that because I wanted to have a really fast attack and to emulate sort of the ringing decay. I wasn't really satisfied with how the release time of the ADSR could be set. So I decided to use both control signals to open up the VCA. So I set both of the ADSR and the AR envelope generators to time factor 0.5, which means they have a very fast curve, and set the release time of both to about half, and this one I set the decay time open in this setting and slightly set the sustain level to create a bit more of a longer sound. Now looking at the output section, we only route the VCA into the mixer, and the mixers then put through a slightly bit of reverb towards the output. So I've hooked up a USB keyboard here, and when I press one of the keys, you can hear the basic sound like this. And I will let you listen to oscillator 3 as well, which sounds like this. And both together they sound like this. So you get more of a realistic, natural vibe, like somebody's playing the drums, slightly different every time. And when I now, for instance, switch on the arpeggiator of this keyboard and press hold, I can just have it play a sequence of notes. Or we can also listen to the pitch. So this is the basic sound, but I wasn't entirely happy with it. So I decided to add some more modulation to the oscillators, and I used the sample and hold for that. So the sample and hold output is hardwired to oscillator 1, and I will turn it up as I play it so you can hear how that sounds. So you can hear some more irregularities in the sound, which makes it slightly more interesting, I think. It also affects the pitch a little bit, but we'll come to that later. The same thing I did with oscillator 3. That was also routed from the sample and hold into this control voltage input, which is normally the noise generator, but by using the patch cord, I was able to apply the sample and hold function to that thing as well. Now let me quickly open up the filter so you can hear what actually is going on in the higher frequencies when I apply the sample and hold circuit. Now let me turn up the clock. So this causes some irregularities, but also in the pitch, and to be able to control this, I have used an external clock, which when I connect this and I play an external clock input, the sample and hold rate is actually clocked towards the tempo of the beat that is playing. So in this case, this was a Behringer RD8, which I used the clock output from. I set it to 4 beats per 4 pulses per beat. So it always is in sync with the beat that will play shortly. Let me show you how that sounds. And we turn down the filter again, so we get more of a darker sound. And when we now change the pitch, we can sort of emulate to different congas like this. I loaded up a software sequencer in my DAW to play the 2600, and for that I used one of the HI plugins, Sequencer Collection 2 sequencers. This is a very versatile software sequencer that we will feature in a later video. But it has all kinds of nice random play functions. So you will hear the drums playing in like a beat that's sometimes slightly off and slightly faster, slightly slower. So that hopefully will create some more of a natural feel to it. Let me show you how that sounds. Now we will play around with some of the controls to let you listen to what happens when you, for instance, change the envelopes or change the filter a little bit. Now, as you can hear, when I turn down the AR completely, you can hear that the sound gets cut off quite abruptly with this fast setting. So that's why I used both of the envelope generators here to get some more rolling off decay type of envelope here. So that's the patch. I will quickly describe the chords again. So this chord is used to get the sine wave inputs to modulate oscillator 1. This one is used to get the pulse waveform output into the filter. And then there is the output of the filter that is run through the ring modulator, controlled by this AR envelope generator to create an extra thicker sound. And finally, this patch chord is output from the sample and hold to have some extra modulation applied to oscillator 3. So finally, I will leave you with a small demo of the RD8 and 2600 playing together to give you an example of what this combination of drums and percussion can sound like. Have fun! Thank you for watching. I hope you enjoyed the video, and if you did, you can give us a thumbs up below it. And don't forget to subscribe to our channel if you want to see more of our videos. I'll see you next time.